So, okay, good morning to all participants. And today let us see the basics of robot kinematics and find the basic of mathematical foundation of robotics. I'm going to introduce these concepts. So, I'm sharing my screen so you can see my screen now. So, before coming on mathematical review, that will consume unnecessary time. Maybe I'm assuming that we are knowing the basic. I'm directly coming on the robot kinematics. Sir, my screen is visible.
Yes, sir, it is clearly visible.
Okay, thank you. So let us understand what is robot kinematics. And right now I'm going to introduce robot kinematics and mathematical foundation of things. Okay. So first, step by step, I will cover the things. This is day 4, introduction to first what is manipulator kinematics. Then we'll see that what is translation and rotation moments, which we have seen in Babos software and other pieces also. So already we defined that robot is a manipulator, which is a kinematic chain. The kinematic chain is a series of links. You can consider like one joint, then you have link, then another joints you have link. So this is we consider kinematics. Because we are doing study about only length and joints. We are not doing study about mass and force. Mass and force. These things I'm not going to deal with the kinematics. These things are once I will read the dynamics of any motion, then we'll read about mass, force, torque, and also. So robot manipulator, whether it is two-link manipulator, it is like human hand. This is hand effector. Like three-link manipulator, you will have 3 links. Human leg is also like a manipulator chain. It is hip, knee, ankle. Okay, so that's why it is considered robot manipulator is a kinematic chain. So an assemble or pair of rigid body that can move with respect to one another with the mechanical constraint. Here mechanical constraint that we can have certain range. Theta can move within particular range, minus 40 degree to plus 50 degree like. Okay, we cannot rotate entire. So there is some constraint you are putting, how much force, what is the length, size, all these constraints you can put. So what is manipulator? That is defined. The rigid body are called links. Here rigid body, that means solid body. These are called links. These are links. Okay, and the mechanical constraint are the joints. In the joints, I can put the constraint. So this is one joint, this is another joint, this is third joint. So joint can move with the particular range. Okay, so theta 1 is ranging with this range, theta 2 ranging with this range, theta 3 is ranging with this range. Okay. Now you can see what is manipulator. I will run a bit fast because we have very less time. So this is the robot name is A150 robotic arm. Okay, the base is fixed. This is base. Okay, and we'll apply some frame here, X, Y, Z coordinate. This is called base frame. Okay, and there is joint frame or body coordinate frame. Okay, and there is we call consider this is tool or hand effector or hand, which you use to help to pick, and there is some object also which we have to place from here to here somewhere. So there are certain joints. Joints depend on number of degree freedom, and these are revolute joints because you are rotating. Then link length, then third joint, then link length, then joint. So this way you are moving. Okay, so these are robotic joints. So how many different type of joints are possible? This is written here. Most manipulator joints are of 2 types. One is revolute joints, another is prismatic. Prismatic when we are sliding over one another. Okay, and revolute joints when we are rotating. Okay, rotating. Revolute and rotative joints link like as a hinge. जो चटकनी और वो that you put on your door. Okay, allow relative rotation around the fixed axis, whether around x axis, y axis, z axis. You have 3 axes, x, y, and z. 3 axes are there. So you can rotate around any of axis. So what will happen if you rotate around x axis theta degree? Anyone who can tell? You can write in chat box or You can raise the hand so that we can see that. Okay, my sound is slow. Still, I'm.
You are audible, sir. No issue.
Okay, someone has written sound is Akhtar Hussain. Sound is okay. Anyway, I will increase bit sound. So now I'm done. So anyone who voluntarily who can answer this one, if I will rotate around x-axis, okay. So it is triaxial things. You can assume that three fingers all are 90 degree, x and y, right? The angle between x and y is 90 degree, y and z 90 degree, and x and z also 90 degree, okay. If we rotate around x-axis by theta degree, and then new coordinate will find x dash, where x equal to x dash, both are coinciding. Both are coming on the same position. What will happen? How much degree y and z will rotate? This is like, you see my hand position, okay. You can see that x and y, and there is z, okay. If I am rotating around this z, what will happen? Y and z will move by that angle. So y will move to y dash. This is, let us assume, y, and this is y dash. This is z and z dash. By how much degree it will move? By theta degree. So as yesterday I was telling, any rigid body have two kind of motion. We have coordinate system x, y, z. So you can move translation around x, y, z axis. These are translation movement. Translation, that means displacement. Another is rotation. Mean you are moving, rotating. Okay. So there is two kind of motion by which you can move. One is translation movement. Another is rotary movements. Correct. So you have revolute joints by which you are moving. Similarly, if you rotate around, this is x, y, z. Now what we are doing, we are rotating around the z axis. What will happen? By angle alpha. So z and z dash will come same position, but x will shift by x prime, y will shift to y prime by alpha degree. Okay. So this is what rotary joints rotation is happening. Is this clear? Any doubt? You can write in chat box. Okay. Fine. Another is prismatic joint, which is like as a piston. You used to press that one, and it used to fill the air over your tire as well as football, and allow relative translation along a fixed axis between two links. So axis of translation around z axis, x axis y. कहीं पे भी translation होता है, rotation भी anywhere you can. Our convention for this study purpose, I will consider the joint I connected to I-1 to link I. Okay. So joint I connected to link. Whenever I'm referring, okay, you have a link. This is link I-1, and this is link I. The joint which is connecting these two links, okay, is referred as joint number I. Okay. If you have Srinidhi is here, can you tell what is the number of that joint when I'm connecting I-2 with the I-1? You can write in the chat box. What is the joint number of this one? The next, there is link I-2 and I-1, and the joint is connecting. What will be the name of this joint? I-1. Okay. Similarly, I. If any other link is there, I+2, because this is serial link, so this is defined by I+2. Correct. Okay. Now I'm coming joint variable. As joint is there, so you have to define joint variable. You will define a joint variable by either theta, alpha, phi, whatever. So revolute and prismatic joints are 1 degree of freedom. Each joints are coming with 1 degree of freedom. So you will have multiple degree of freedom. Thus can be described by using the single numerical value of the joints. In case of joint, I am defining by the qi or theta I. Okay, in case of revolute joints, this qi is the theta I, angle of rotation between I relative to I-1. And prismatic joints, I'm writing the di, that means displacement. And displacement happen between I-1 and I. Okay. So I joint is referring the starting points. Now let us see the revolute joints operation. So revolute joint variables, like you have link length I-1, link I, you have theta I, you are revolving around by this variable Qi, which is theta I. Okay. Similarly, prismatic joints, you are pressing the things that is represented by the displacement d. Then there are different kind of manipulator: RR manipulator, RP manipulator, PP manipulator, triple RR 3-degree manipulator, RPR manipulator, PRP. So R is for revolute revolutes. You can have two joints revolute joint. You can have combination of revolute plus prismatic. You can have prismatic prismatic. So most industrial manipulator has 6 or fewer joints. More than 6 joints you will not find. As you have seen that this industrial manipulator, it has 6 joints. Okay, joint 1, joint 2, joint 3, joint 4, joint 6 maximum we can go. More than this we cannot expect. The first joint, why it is 6 joints we are considering? Because human head has 6 degree of freedom. 2 at shoulder. Okay, you can rotate the shoulder, you can move front and back. Then 1 at your elbow. Okay, wrist has 3 degree of freedom. Roll, pitch, and yaw. Okay, around X, Y, Z axis rotation. So up and down, left and right independently, and we can rotate. Okay. So this is 3 degree of freedom. So first 3 joints are of arm, and the remaining 3 joints for wrist. So anyone who can write in chat box, the wrist joints are revolute joints or prismatic joints or arm joints. So such a common describes such a manipulatory unit joint of the arm by the revolutes and prismatic. So first 3 joints of arm are considered as the revolute joints, and last one prismatic. Why prismatic joints? Because we have to move, we have to touch the object, we have to pick object. So हमें move करना होगा. Maybe we have reached orientation by perfectly, then we have prismatic joints. Okay. You can see the example. This is your wrist, this is your shoulder, this is your forearm, and elbow. Sorry, waist. This is your waist, this is your shoulder, this is your elbow, and their forearm. So you have 1 degree of freedom here at waist, and the this is Z0 axis, then Z1 shoulder, and this Z1 is telling you are rotating around this axis. And always you are rotating around whatever axis, whether it is X, Y, Z axis, these 2 axes will move. So always keep your Z axis around your rotation, perpendicular to your rotation. If you are rotating here, you keep Z axis in perpendicular. If you are rotating here, you keep in Z axis in upward. If you are rotating like this, so keep here Z axis perpendicular. If you are rotating like this, keep Z axis. If you are rotating like this, keep Z axis perpendicular to it. Okay. So Z axis always in the direction of rotation. So then according, if you move Z, then X and Y. So you see that you are rotating around here. So Z axis is coming perpendicular. If you are rotating here, Z axis is coming perpendicular to this theta 2 and then Z3. So waist, shoulder perpendicular to Z0 and elbow is parallel to Z1. So you see that Z1 and Z2 are parallel, but Z0 and Z1 are 90 degree. There is 90 degree angle and there is 0 degree angle or 180 degree. So the popular manipulator is RRR kind of things, 3-link manipulator, which has 3 revolute joints. Okay. So you can see that standard arms are there. Okay, so one is spherical manipulator. This is revolute articulated manipulator. Articulated manipulator is that in which you have to write something or design something. That time we used to consider articulated manipulator. Another is spherical manipulator, in which we have first 2 joints are revolute, last joint are prismatic. So you have waist theta 1 rotating, theta 2, and here you have displacement. Then you have SCARA manipulator, which is RRP again, revolute, and prismatic. Those direction is changing. So the SCARA meaning is selective, compliant, articulated robot for assembly purpose. Okay. Now let us move kinematics, forward kinematics, inverse kinematics. Okay, so you will define like this. This is your x-axis. This is your y-axis. Okay, this is, let us consider this is 2D architecture. So I'm considering xy. This is theta degree. It is rotating. The link length is a1, then theta 2. So how much this value will be? This is again theta 1, and this is my end effector position, which will be x1 and y1 या x2 y2 कर लीजिए इसको. This position is x1 y1 and this is your x0 and y0. Okay, suppose I need to calculate x1 and y1. What will be the value of x1 and y1? Can you write in chat box? क्या होगी? The link length is a1 and this angle is making from the axis theta 1. So how much value is this? This is a1 cos theta 1. What is the value of y? This is y1 sin theta 1. Now what is this? This is theta 1 plus theta 2. And what is this value? From here to here, this is x1, a2 cos theta 1 plus theta 2. And what is this value? a2 sin theta 1 plus theta 2. This is clear to everyone? So in this case, what is the value of x2 we are achieving here? x1 plus a2 cos theta 1 plus theta 2, where x1 is a1 cos theta 1 plus a2 cos theta 1 2. Similarly, y2 equal to a1 sin theta 1 plus a2 sin theta 1 plus 2. This is end effector position we are getting. Is this clear to everyone? If it is so, now we have to define what is joint. There is two space in which we can talk about. One is end effector position, that is x, y, and phi is the orientation. Okay, end effector is not always coming in 0 degree. It has some rotation. So x, y is the position at this point and phi is this angle. Okay, so we are representing, this is your Cartesian value. Cartesian coordinate. And there is joint coordinate, which is theta 1 and theta 2 in this case. Joint coordinate. So you can convert the value of Cartesian into joint space, and from joint space you can come Cartesian. So if joint space value is given, if I will ask you to move your shoulder by 20 degree, elbow by 30 degree, you will reach at unique position. But if I will ask touch your nose, you can touch your nose by like this way, various other way you can come by the other way. Those I will looking for energy optimality, but we have multiple solutions. So if joint space value is given, you are getting unique spatial coordinate. Okay, but if spatial coordinate or Cartesian coordinate is given, we are getting multiple values. So that's why forward kinematics, this is the case of forward kinematics when joint space value is given, but when reverse inverse kinematics. Okay, if Cartesian value is given, you have to calculate joint space. So given the joint variable and dimension of the link, what is the position and orientation? So joint element theta 1 and theta 2. Two dimension data is there. You have to calculate x, y, and phi, which is end effector position. So from joint space to this is called forward kinematics, quite easy, unique solution you are getting. But in case of inverse kinematic, what is happening? So easily you can see that choose the base coordinate frame of robot. I have selected x0, y0. We want to express this xy. What is this xy value? This is a1 cos theta 1 plus a2 cos theta 2. You can see here. This is a1 cos theta 1, a1 sin theta 1, then another frame x1, y1, then another frame a2 cos theta 1 plus theta 2, and this one. So final the position of x is a1 cos theta 1, y equal to a sin theta 1. In forward kinematics, I'm getting theta 1, theta 2, a1, a2. So you can easily calculate xy. In inverse kinematic, what is happening? We have value x and y, a1, a2 is known, but theta 1, theta 2 are unknown. So you can represent in form of matrix also. Cos theta 1. Okay. So because the base frame and frame I, one has same orientation. So generally each time we used to attach one base frame, another body coordinate frame. So in case base frame and the first frame are same frame, so their orientation is same. So 0 number frame and 1 number frame are same. Okay. And the joints which is referring joint A2 and A1 is referred by the joint 1, which is referring A0 and A1. This is referred joint 0. Okay. we can sum the coordinate to find the position of any vector from the base frame. Okay. We also want the orientation of frame 2 with respect to the base frame. Okay. So this is theta 1 plus theta 2. Now I need to find the orientation of this one. So x2 and y2 expressed in term of x0 is there here. Cos theta 1 plus theta 2, sin theta 1 theta 2, y2 equal to minus sin theta 1 theta 2 and cos theta 2. So given the position, because what is happening, the end effector also can move in various directions. Those I got the x and y, but I need orientation also, because it is not always coming in this direction. Maybe it is like this. It is rotating by certain degree. Okay, I need to calculate that rotation. So we want to find the orientation of frame 2 with respect to base frame x2 and y. So the base frame is t0, and this is your rotation. So with respect to this one, I am looking. So what is x2? Cos theta 1 plus theta 2. Okay. Another is sin theta 1 and sin theta 2. This is x2. And the y2 is minus sin theta 1 plus theta 2 and cos theta 1 theta 2. Because you are moving there. Okay. With respect to this frame, you see that this is your x0. This is your y0. What is this angle? This is theta 1 plus theta 2. And what is this angle? This is again theta 1 plus theta 2 in negative direction. Okay. Now I need to calculate x2. x2 कितना होगा? x0 का एक कौन सा कंपोनेंट होगा? sin cos theta 1 plus theta 2. Okay. Similarly, y2 is there minus sin theta 1 theta 2 comma, because two coordinate things. So given the position, possibly the orientation of an effector, the dimensionality of link, what are the joints variable? Joints variable are theta 1 theta 2. Now I'm coming on inverse kinematics. Okay. So inverse kinematics, what is happening? You have given the position, last xy की value दी है, x2 y2 की value, and you have to calculate theta 1 theta 2. So what is happening? This is hard than the forward kinematic, because there is often more than one solution possible. You can reach by both way. This is your workspace in which you are working. You have multiple solutions by which you can get this one. So you have multiple things. Okay. So multiple solution, that's why it is difficult. Okay. Now let us solve inverse kinematics bit for two link manipulator. Forward kinematic already we have solved. What is forward kinematics equation? X and y. कैसे मिलेगा x and y? This is a1 cos theta 1 plus a2 cos theta 1 plus 2, y equal to a1 sin theta 1 plus a2 sin theta 1. This is what forward kinematics. But inverse kinematics is hard to find, because often, and I need to find the theta 1 and theta 2. कैसे मिलेगा उसको भी देख लीजिए. We have to write the equation, do some geometrical operation. X and y, two link manipulator I am considering, because three link manipulator solution you can get from two link manipulator. Just recursively you can solve. Four link manipulator solution, base is 2, then 3, then 4, and this way I can go. So x square plus y square is what? A1 square cos square, a plus b का square आएगा और a plus b, तो a square b square 2ab. So a1 square cos theta 1 square plus a2 square. So in this case, cos square theta and sin square theta is coming. This is 1. So I'm getting a1 square. Similarly, a2 square you are getting sin square cos square. Then 2a1 a2 cos theta 1 2 plus sin theta 1 and sin theta 1 2, which is cos a cos b sin theta 1 sin a. This is cos a minus b formula. So cos a minus cos b क्या है? ये है. So you are getting cos theta from here. So what is the value of cos theta minus cos theta? You are getting x square plus y square minus a1 square minus a2 square divided by 2a1 a2. That is what I'm getting from here. Okay, this is what written here. And you can use trigonometry based solution. I am using the geometrical solution. You can use trigonometry based solution. So in case this is theta 2, this is your theta 1, okay. This is your A1, this is your A2, B equal to. So what is this angle? Anyone who can tell? This is 180 degrees, this is theta 2, this is pi minus theta 2. And what is cos theta? Cos theta क्या होता है? A1 square plus A2 square minus B square upon 2A1 A2. So what is happening? Cos this angle, cos theta is, suppose this is like angle A, angle B, angle C, the C, B, A. If I need to find cos C, what is cos C? B square plus A square minus cosine formula upon C square upon 2 A and B. Okay. So what is your cos C? This is cos pi minus theta 2. What is in front of in jointing the joints? A1 square plus A2 square. What is diagonal? Minus B square upon 2 and A2. Okay. And what is B? Anyone who can tell me B? Because this is your X and this is Y and this is 90 degrees. So this is hypotenuse. So B is क्या है यहाँ पे? X square plus Y square. B को उससे replace करोगे तो क्या होगा? A1 square, A2 square minus X square Y square upon 2. एक cos क्या होगा? Minus cos theta होगा तो क्या आ जाएगा? Minus उधर चले जाएगा तो X square Y square minus 2 A1 square minus A2 square upon 2A1 A2. This is what formula you can get. So this is written here. Cos minus theta is cos theta. So you got the cos theta. Similarly, you can calculate the cos 1. Okay. Sin square cos square theta is 1, tan theta sin theta. This formula you should know. In MATLAB, you just need to write 3-step solution. Cos theta, sin theta. Sin theta is root square 1 minus cos square theta. And always we are representing angle in the robotics is A10 formula. That I am not going this. A10 which requires sin theta value and cos theta value. A10 function. It is like tan inverse. Now theta 1 also you can calculate. How you calculate theta 1? If you have value the theta 2, how you can calculate theta 1 from here? Anyone who can guess? Theta 1 की value आ गई, theta 2 की value निकालनी. From same equation I will utilize. So where is theta 1? This is. Or either I know that what is this value? This is your theta 1. This is theta 2. This value I know that this is your A2 sin theta 1 plus theta 2. This is your A2 cos theta 1 plus 2. If I see that cos theta 1 plus 2 या 10 theta 1 plus theta 2 आप ये कर सकते हैं, ठीक है? So here what you can get 10 क्या होगा? A2 sin theta 1 plus theta 2 upon A2 cos theta 1 plus theta 2, ठीक है? यहाँ से theta 1 theta 2 आ जाएगा 10 inverse whatever value is here, and theta 2 already you are knowing. Theta 1 you have to calculate. Theta 1 equal to whatever 10 inverse value is here minus theta 2. And theta 2 what you calculate theta 2? This is cos inverse this one. Okay. So what I am writing? Theta 1 equal to 10 inverse y upon x minus theta 2. Okay. This is clear to everyone? This we have solved. If I calculate theta 1, so I need to calculate theta 1 value. For this, what I will do, I will calculate tan inverse 10 theta 1 plus theta 2. What is 10 theta 1 plus theta 2? This is A2 sin theta 2 and this value A1 sin theta 1 you are getting. or either you consider this phi angle. This is tan phi. Okay, tan phi is what? Y upon x. This tan phi is y and x. Okay, so phi equal to becoming tan inverse y upon x. What is this phi? This phi is what? This is your pi minus theta 2. Okay, this is your theta 1. So theta 1. And if you want to calculate this angle theta 2 only, so what you have to subtract from there. So phi minus theta 1. Okay. Sorry. Anyone who can tell me this solution? Very easy solution. What is tan phi 1 plus alpha? Samriddhi, can you tell me the answer? Sujit, can you tell me the answer? What is tan phi plus alpha? क्या होना चाहिए? Y upon x होना चाहिए. So y upon x. Okay. So then theta 1 plus alpha equal to becoming tan inverse y upon x. Okay. Now I need to calculate theta 1. तो कैसे होगा? Tan inverse y upon x minus alpha. Alpha की value कैसे निकालोगे? This angle. Okay. So this angle you have to calculate. This is cos alpha भी ले सकते हो. Okay. This I know that this is theta 1. Okay. So cos alpha के case में this is your a1. Okay. This is a1. Okay. What is this height? This height is a2 sin theta 1 and this height is a1 plus a2 cos theta 1. Okay. So this is what alpha value is coming. This is you can capture. Okay. So I think that this is clear. Okay, no problem. Now I'm coming a special description. A little bit it is very basic. Any point and dot in any where you are defining it is vector. Okay. So you can define the vectors.
Sorry to interrupt you, sir. One participant would like to ask a question, right?
Yeah, please.
Answer. Sripad Sarangi.
Yes, please.
I have unmuted you.
Yeah.
Yes, sir. Regarding this rotation, I was a little bit confused. So I suppose I was just confused in that step, sir. Can you please repeat that earlier question?
This one. This you are asking theta 1 or theta 2?
Theta 1, sir. Theta 1.
Theta 1, na? That is easy. Okay.
Yeah.
That I will take. I have solution. I am directly coming on solution. Those I am trying to solve. The solution I will show you. There is two ways by which you can solve. One is geometrical solution, another is algebraic solution. Okay. Whatever solution you want to apply, you can see. Geometrical solution I am telling. Theta 1, theta 2 is clear. How I calculate theta 2, x square, y square minus a1 square minus a2 square upon 2l1 l2. This is clear. Theta 2 is there, then theta 2 is becoming cos inverse, and either you can term sin theta 2 also you can calculate. You can put in a tan 2 function or tan inverse. Now I need to calculate theta 1. Okay. So for theta 1, you can cosine formula already you apply. Now you apply law of sine. So what is law of sine? If you are this is angle A, this is angle B, this is angle C. This is your A, sorry, B. This is your A, this is your C. if I will do sine, what is formula? Sine A upon A होता है equal to sine B upon B. This is sine formula. Sine C upon C. We used to constant है या कुछ है ना? So if I am considering this angle, sine A upon A and sine B upon, so sine, from here I can get easily this derivation. So what is sine B? I am considering this is suppose alpha plus theta 1. Okay, so here from sine B angle is consider that in this rectangular I am considering. Okay, so sine B upon B, sine C upon C, which is like sine 180 minus C, and this one. From here you are getting the value of alpha. Alpha equal to theta 1 plus this. So this I will solve with this reference to this one. What I was solving here. We'll refer here because the notation will become different. This is coordinate x and y. This is link length A1. This is link length A2. The angle is formed is theta. This angle is formed is theta 2. This is again theta 1. This is your, suppose this angle is alpha. Okay, so either you can consider entire angle alpha, so tan alpha you can go either. You can go tan theta 1 plus alpha. Tan theta plus alpha mean I am talking about this angle. So it will give value tan क्या होता? Y upon, this is y and this is x. We are getting, so which is here tan inverse y. So from here theta 1 plus alpha equal to tan inverse y upon x. Only to calculate theta 1 you need to find the value of alpha, and that is confusion. So I am getting this alpha. So what I have to do, I apply some rule, sine rule. Okay, so you can have like this. Okay, this is your alpha. This is how much angle? This is theta 2 and this is pi minus theta 2. Correct? Two angle I am knowing. This is your A2, this is A1, and this is x square plus y square. Is this clear? Why it is x square plus y square? Because this is right angle. Is this clear?
Yes, sir. Yes, sir. Clear, sir. Now it is very clear. Thank you, sir. Thank you very much.
Now what you will do, sine alpha upon A2, है ना? So how much?
Yes,
है ना? And similarly, this is A1 cos theta 1. So you can have sine alpha upon the angle in front of A2 equal to sine pi minus theta 2 upon x square plus y square. This way also I can go. So from here I can get sine alpha equal to A2 sine theta minus theta 2. So it is becoming A2 sine theta 2, but upon x square plus y square. Okay, so alpha is sine inverse, but I'm writing in tan inverse form, so you have to calculate cos also. Then sine theta upon cos theta you will do. You can easily get this. So this is clear. Now I'm coming on special description. So any point in the free body or anywhere, it is represented by the vector. It has, if it is 2D, you have to coordinate x and y, which has magnitude as well as direction. So magnitude is the length and the direction of the 2 points vector. Okay, which you can represent. This is your base frame. Base frame is represented by 0, so which is O naught base frame. It has x naught and y, and there is another position P. How much far it is? So what is happening? P naught is if 4 and 2.5. Q naught is given 2 and 0.95. The value this V naught will be P naught minus Q naught 2 1. Okay. So choosing a frame, because there is one fixed frame. With each object there will be one fixed frame and one base frame. Suppose the bus is moving. The bus is moving, keep continuously moving. At 9 it was here, at 10 it was here, at 11 it was here. So there is body coordinate frame is always moving with the bus. So position P0, P1, P2 is changing of the bus. But base frame is, which is I'm considering, sorry, this is P1, P2, P3. Object is moving and the base frame is always still. That is the your original station. Okay. So how far you have went? This moment. Okay. So how far you are from origin? this much vector. You can calculate. Okay, so that we have to choose. So there is body coordinate frame and another coordinate frame. Okay, so choosing a frame, a point in the two perpendicular vector of unit that allow us to assign a coordinate frame. Okay. You can have different base frame also, frame one from different direction. You can say that in this time I'm having negative direction. The coordinate change depending on the choice. So once base frame is changing, it is changing the things also. Depend on the application we used to do. Now let us see the dot product of two vectors u and v. So if it is n dimension vector, okay. So if you take the dot product, and already I told that the dot product always giving the projection of this vector over u in this. So there is unit vector v. So if it is unit vector v, so the magnitude will be 1. So u cos theta. Okay. So it is telling if you take the dot product, it is directly telling the projection of u over v. And what is u? u1i, u2j, I and j are unit vectors around x, y, z axis. u3 k and v equal to u1 v1i, v2j, v3k. If it is cos 90, the value will be 0. Cos 0 angle, it is 1. So that's why what is happening in u and v, if you are multiplying dot product u and v, it is giving u, v and dot product of I dot I. So both are same. So I dot I is modulus of I, cos 0. Cos 0 is 1, I and I is unit vector, so magnitude is 1, so you are getting just UV. So whenever you are taking dot product to vector, it is just multiply u1 v1, u2 v2, u1 vn. Okay, you can do. And you can write like u transpose v. So u1, u2, u1 is u transpose, and v is v1, vn. This is 1 cross n, and this is n cross 1, so you will get unique scalar quantity, some quantity. Okay, it will tell the position of vector over you. So what is translation frame? As I told that each manipulator you have translation as well as rotation. Like initially your coordinate was here, then bus has moved here, then your frame has translated with this one in x-axis direction, y-axis direction. Then it has little bit tilted also. So the coordinate frame also moves. So it has translation as well as rotation. Okay. So suppose 0, 1 is expressed in the frame 0, and we have to express this 0, 1 in frame 1. So what is happening? Around x-axis, it has translated by what distance? This distance t. Okay, y-axis is same. So that's why it is written by 3 around x-axis, y-axis is 0. Now, I need to represent the frame 0 with respect to frame 1, so I need to subtract minus. So frame 0 value is something 3, 0, and this is 0, 0, so this is getting 3 minus. So minus 3, minus 0, okay. The translation vector di can be interpreted as the location of frame j expressed in frame I. Okay, with respect to if you are writing like di comma, generally I will use this one. So here I'm expressing frame j with respect to I. Those they have used this notation, but I will use this notation. Frame 1 with respect to 2. So we are finding the position of 2 with respect to 1. Somewhere you find like this also. Here you are writing 2 with respect to, but we'll use some uniform format. So in this case, I'm considering, let us stick with their notation. Dij, that means they are expressing the location of frame j in frame I. So frame j location they are representing the j. So the suppose some point is 1 with respect to the frame 1. So this is 1 and 1. Okay. I need to calculate with respect to this one, P0. So what I have to do, what is the position of this frame? O0 over 1, this is 3, 0. And then you add 1 and 1. It will become 4 around here and 1 around here. So the coordinate will become 4. So the moment you will change the base frame, the vector value will also change. Okay. Translation of vector Dij can be interpreted as the coordinate transformation point of frame j to the from I. Okay. So now Q2 is here, 2, 1, P naught is the minus 1, 1, and the base frame is Q naught, Q1. That means with respect to this one, you can represent like, okay, this is 2, this is 1. Here you can see this is minus 1 and this is 1. Okay, so Q naught is expressed in frame 0. So how you can express Q naught in frame 0? What is the position of this frame? 0, 0. Initially 0, 0. Okay, and then how much we are moving in x direction? 2. How much we are moving in y direction? 1. So we are getting 2, 0 for Q naught. For P naught, what is there? What is the value of P naught? P naught is this one. Okay, and I need to express 0 with respect to P naught. So what I will add, P naught may add करना तो minus 1 and 1 I need to add. Okay. So we will not go in much depth of this one. The translation vector D can be interpreted as the operator that can take point and move into the some direction translation moments. Okay. Now I'm coming in rotation. That is very important, and I will finish also my talk with this discussion of rotation, translation, homogeneous transformation matrix. So far I was discussing about only 2 frame and 3 frame. I told that if you are rotating around X, Y, and Z axis by theta degrees, so it is rotating Y and Z axis, but it is X and X prime axis is same. Okay. So what is happening? Translation was possible. Now rotation is there. So the frame is moving with respect to previous frame. The frame has moved X naught to X1 by theta degree and Y naught to Y naught by theta degree, and the frame both are O net and O1 is originated. So this is X1 cos theta 1. This is Y naught sin theta 1. Yeah, Y1 sin. This is sin theta component. This is cos theta component. So the rotation matrix you can represent by 2 cross 2. How much X naught and X1 is rotating? How much Y1 is rotated with respect to X1? How much X1 has rotated with respect to Y naught? And how Y1 is rotated with respect to Y naught? Okay. Rotation matrix you will define. Because you have rotated X naught and Y1. So you have to see with respect to X naught how much X1 and Y1 has changed. So you are looking here X naught or X1. X naught and Y1. X naught के respect में X1 Y1 कितना घुमा, Y naught के respect में X1 Y1 कितना घुमा. So can anyone will tell answer what is the value of X1 and X1 dot X naught? All are unit vector. Cap is there. So क्या होगा modulus of X1, modulus of X naught and cos theta. ये 1 है तो this value is represented by the cos theta 1. Y1 and X naught के बीच की value कितनी है? This is 90 plus this angle theta. So 90 plus theta क्या होगा? Cos 90 plus theta होगा sin theta. Okay. Similarly, you have X1 and Y naught. X1 and Y naught. These are 90 degree. Sorry, not 90 degree. This is 90 minus theta. 90 minus theta तो क्या आ जाएगा? Sin theta. And Y1 and Y naught, this is just cos theta. So already I've calculated this matrix. So we'll simplify this for 3 plus 3 dimension. This I calculated. Now, with respect P1 with respect to O0 frame and P1 with respect to O1 can be mapped here. Okay. So P0 is representing with respect to O and P1 is this one. So you have just rotation matrix. What is this rotation matrix is telling? The rotation of frame 1 with respect to frame 0 is represented by cos theta, sin theta, cos theta, sin theta. You can multiply that. Okay. Now let us see what is the property of these rotation matrix, because finding inverse is always difficult, because this is okay. But if I need to find P0 with respect to Q0, then I need to go for R inverse. And R inverse you require adjoint R upon modulus of R. If it is singular matrix, modulus will become 0, it will become infinite, and maybe you will not find the solution. Okay. So for this, and that is singular configuration. So the rotation matrix probably that has the transpose of matrix. If it is orthogonal matrix, the transpose and inverse will become same. Okay, so these are orthogonal matrix, so the transpose and inverse is same. The column of R is mutually orthogonal. That means 1, 2, 3, 4, 5, 6, 7, 8, 9 are mutually orthogonal. So if you take the term, that term in orthogonal matrix, each column of R is uniform. The sum is uniform 1 square plus 2 square 3 sum 1 आना चाहिए, and the determinant is G. That is the property of rotation matrix. Okay. So translation was moving, rotation was rotating. Now you have translation as well as rotation. You are translating around x-axis by certain degree d, y-axis du2, and then rotating also. This is x0 and this is y0. So how will define? So we need combined matrix by which I can represent both translation as well as rotation with single matrix. So for this, I can check the 3-dimensional matrix also. As we have 2-dimensional matrix, now I have 3-dimensional matrix x1, x0, y1. So rotation in 3 axis. If you solve this one, then I'm coming on rotation. Already I told the property. Now what I'm doing, I'm rotating around x-axis. क्या हो रहा है? केवल y and z is moving. Or here I'm rotating x1, y1 and z1 all three. Okay. So if you are rotating around z-axis by the theta, so x is shifting by theta, or y is also shifting by theta. So that you can represent. Even similarly, if you rotate around x-axis, y and z is shifting, and you can see the demonstration. Euler angle is famous Euler angle. The animation. This is your x-axis, y-axis, z-axis. Okay, all are perpendicular. Now what you are rotating around z-axis. So what will happen? Y angle. So W prime will come, which is very similar to the z, but x will shift by the x prime with the 5 degree, while shift by the y prime, that is the 5 degree. Okay. Now again I'm rotating around u axis. What will happen? V and W will shift theta degree. So u and u prime double prime are same, but we will shift by the v prime, and W will shift by the W prime by the 5 degree. Okay. That is what we consider Euler angles. Now I'm rotating around again FIFA around W prime, W double prime, W3 prime move, but B double prime will move and U double prime will move by the. This is what how by animation you have visualized the rotation. अगर ये रोटेशन होगा तो अब मुझे कैलकुलेट करना है. So suppose what I am doing that I am rotating around z0 axis by 45 degree. That means I am doing rotation around z axis by 45 degree. So 45 डिग्री का रोटेशन हो रहा तो ये भी 45 डिग्री आएगा और ये भी 45 डिग्री आएगा. And I need to find 3x3 मैट्रिक्स है. First I will see that how x0 के रिस्पेक्ट में x1, y1 and z1 मूव हुआ, then x1 के रिस्पेक्ट में, then y1 के रिस्पेक्ट, sorry y1 and z0. How with respect to x0, x1, y1, z1 का डिफरेंस है, y1 के रिस्पेक्ट में कैसा डिफरेंस हुआ y1, y2 का, और okay, from here you can get rotation matrix. So anyone who can tell x1 or x0 कितना एंगल है? x1 and x में, this is cos 45 or cos theta 2 relatively. y1 and x0, that is again 90. This is 45. Okay, rather this is 90 degrees, so 45 angle you are getting. You can check these things. Okay, so we are representing frame R1 with respect to frame 0. What is this? It is just rotation around frame Y by the 5 degree. Okay, now the frame 1 with respect to 2, what is happening? It is rotating around theta with the z. Okay, that is the rotation. So many times you have multiple. Suppose you have to see the frame 2 position with respect to 0. So first you will see the frame rotation of frame 1 with respect to 1 and then 1 respect to 2, that you can see. Okay, now you see that matrix rotation around XY axis. Okay, this is translation. Okay, I will show that rotation matrix. These are the angle you will get, okay, when you are rotating around Z axis. Now you are rotating around Z axis by theta degree. So क्या होगा, X move करेगा by theta degree and Y move करेगा by theta degree, and this will become Y1, sorry, X1, Y1 and Z1 will become same. अगर आप रोटेशन की फॉर्म में लिखोगे RZ by the theta degree, so what will happen? You have to consider x के रिस्पेक्ट में x डॉट x1, y1 x के रिस्पेक्ट में, z1 x के रिस्पेक्ट में. सिमिलरली y के रिस्पेक्ट में, z के रिस्पेक्ट में न्यू फ्रेम का क्या पोजीशन. So x1 and x0 there is just cos theta. Y1 and x is 90 plus theta. 90 plus theta, so this is your sin theta minus sin theta. And z1 and x1 क्या है? Exactly z and x 90 degree और z1 x1 is 90 cos 90 0. x1 and y, this is 90 minus theta, so sin theta just. y1 and y just cos theta difference. And z1 and y, so z1 has not rotated, this is always perpendicular axis, so this is again 0. x1 and z is again cos 90, y1 and z is cos 90, and then z and z is same, so this is 1. This is what rotation matrix around z axis, rotation matrix around y axis, rotation matrix around x axis, you will get like this. This is what this division, and you just use this rotation matrix. Okay, now you have to merge rotation as well as translation. So what you will do, singular matrix, I need to prepare homogeneous matrix which cover translation and rotation. So उसके लिए मैंने क्या किया कि I merge. So first this column is kept 3x3 matrix for rotation, and one extra matrix I have created for this displacement around XYZ axis. So this is rotation around rotation matrix, displacement matrix, दोनों को multiply करिए. And I have done padding so that it become 4x4 matrix. Otherwise क्या बनना था, 3x4 की matrix बनी थी. So homogeneous matrix we require. So we have done this. ठीक है, तो ऐसी मैट्रिक्स बन जाती जो ट्रांसलेशन और रोटेशन दोनों को कवर कर लेती. Numeric also you can solve if you are interested. Okay, we'll see some more things.
कल स्क्रीन टच कर रहे थे पूरा की स्क्रीन टच
Any question? Any question? Any question? If participant is looking, we can take. I'm coming back to my original discussion. Now I'm coming on the rigid body transformation. Acha, the one question is when to consider the Euler angles. So you know that when you are landing, aeroplane used to land on the ground. You know how they used to land? They used to follow Euler angles. Okay, roll, pitch, and yaw. जब land करता है ना, take off is okay, but during landing, how to touch the aeroplane on the ground? That time they are using this Euler angle. These kind of things. If by the theta degree you rotate here, then you'll take translation as well as all things. And the manipulator it is using. Now coming on the homogeneous representation, let us must translation representation of vector D. Rotation we are representing here. Matrix by matrix or matrix vector multiplication and vector addition. I request Suman sir, Amit Kumar ji, can you mute yourself? The sound is coming. Yeah, kindly mute yourself. The sound is coming.
जो आ गया तो उसको तो अटेंड करना पड़ेगा जो भी पूछेगा उसको बताए जो भी पूछे क्या जो उसको प्रॉब्लम किसी ने ड्यूटी लगा दी किसी की आते थे ऑफिस वाला कुछ नहीं बताता वो कहता कॉन्फ्रेंस तो प्लीज क्या क्वेरी है बताइए
Can we mute everyone? I request everyone to mute yourself. The sound is coming.
हाँ मैं बैठ जाएंगे क्या हो गया बैठ जाएंगे क्या हो गया बैठे अपना काम करते जब आ जाते बता दीजिए यहाँ बैठे जो भी पूछेगा जो हमें पता अरे भाई और भी तो लोग हैं सर आपने बर्डन उठाया जो यहाँ बिल्कुल ही कहीं नहीं आ रहा उसको भी तो कुछ दीजिए
Nasim ji, can you mute yourself?
अरे भाई जो फिजिकली आगे वो क्या करे वो तो आया वो तो अटेंड तो करोगे
Nasim Rai ji, can
अगर
you
आप
mute
उससे
yourself?
बात करो वो एडमिशन नहीं लेगा वो भाग जाएगा कि यार वो उसके पास भेजता है वो उसके पास भेजता है ये नेगेटिव चीज है एक आदमी चल के आया पसीने पसीन उसको हो रहा है हाँ लॉजिकली गलत है ना इसको बताइए अरे भाई
Dharambi sir, maybe you will have right to mute all option.
I have muted him, sir.
Okay, thank you, sir. Correct. Okay, so let us move ahead. Now let us prepare the homogeneous transformation, which will incorporate your translation, because translation is 3x1 vector. You are only translating around x, y, z axis. So this is 3x1 vector. Rotation, this is 3x3 matrix. So in case of matrix and matrix to vector multiplication is possible. You can easily multiply one matrix with the vector. The operation is required. When you have translation only, you can just have px, py, pz, and you do addition. Okay. In case of you have rotation matrix, you can multiply with the this one. This is 3x1 and this is 3x3. You will get 3x1 another rotation. So convenient to have uniform representation to translation and rotation. एक matrix बना दी जाए, no need of creating separate matrix. So obviously vector addition will not work for rotation. Okay, because this is matrix, rotation is matrix. So can we use matrix multiplication to represent translation also? कि multiplication से matrix multiplication possible, but vector addition can be not be do during matrix. So what we'll do, we'll represent the matrix, okay, for translation also. So consider the moving point P by the translation vector D. So translation vector dx, dy, z, xy, and this is your position. So you can get the translation. For rotation, आपको करना हो px, py, pz को अब करना होने हैं. How we can replace this matrix so that we can get this translation also with the help of matrix, not only by the vector addition. We can multiply with the translation matrix. कर सकता है? Anyone who can answer me? कोई आंसर दें मुझे? Anyone, the participant who is interested can raise hand. Can you replace this question mark? ये आंसर आ जाए. कहाँ पे dx dy dz रखूं? Can I do like dx because I want dx plus px. So यहाँ पे आप multiply करोगे 1 1 1. So can I do 1 1 1 and dx? Can I take 4 cross 3 matrix, 3 cross 4 matrix? Sorry, 4 cross 3 matrix I can take, 3 cross 1 matrix I can take. What I will get? I want a 3 cross 1. Okay, so 3 cross 3 matrix ही चाहिए. Anyone who can answer?
Sir, I
1
think
0
dx 0 0 in first line. Then
If I will
0
dx 0 0
dy
I will
0.
put 0
Then
dy
0
0.
dy 0. And then 0 0 dz. I think.
Correct. But what will happen? यहाँ पे क्या जाएगा? Px into dx. It will get px into dx. It is not giving. Those you are eliminated. You have to add. You have to extra add somewhere. Is it possible? So
Okay,
what
okay,
I can do? So some modification. This is good. You have tried best. You have reached to the solution. Somewhat I can go 1 0 0 0 1 0 0 0 1. I'm getting px, py, pz. But there is one problem. Still I'm not getting dx dy. Somewhere I need to add this. So dx dyz को मैं एक extra column बना लूँ यहाँ पे. dx dy dz. Now I am matrix 3 cross 4. And this is 3 cross 1, which I cannot multiply. 1 minute है ना? 1 minute I will return back. So good try. Now dx dy 3 cross 4 हो गया. क्या 4 cross 1 कर लूँ उसको? Can I do 4 cross 1? I can add one extra cheese here 1. So क्या होगा? Px into 0. There's two quantity will become 0 and this is dx. So this solution will work. Correct? If I can do 1 0 0 0 1 0 0 0 0 0 0 1 and I can add 1 1 1. Okay. And then I'm adding dx dy dz. Last column I'm keeping for translation. And then you have px py pz and I have added one here. This is becoming 4 cross 1. This is 3 cross 4 and ultimately we are getting 3 cross 1. So now 1 into px, 0 into py, 0 into pz and dx into 1. You are getting this. Getting my solution? I think that this is clear. Fourth column we have added. But this is not homogeneous. Okay. This is not homogeneous matrix. So this same thing they have done here. 0 0 0 0 1 and 1 here. But this is 3 cross 4 matrix. This is 4 cross 4 matrix. 3 cross 4 matrix, 4 cross 1 matrix, and this is you are getting 4 cross 1. Extra one I am adding unnecessary. Why I am appending this padding bit so that it can become the square matrix 3 cross 1. Clear? Everyone has to clear? Is this clear? So almost you learn translation and rotation. You have merged the things, so now you can do easily. Very perfectly. I have seen the answer, Dr. Manjula. That is correct. So now what is happening? First 3 cross 3 matrix is rotation. Last 3 cross 1 matrix is for displacement. You multiply. So you just want a rotation, you will make displacement 0, 0, 0. So जो यहाँ पे किया गया वैसे हो गया. So what is happening here? Frame B0 here, frame 1 is here, frame 2, and the drone is moving from here to here. So this is just displacement and rotation. Displacement and rotation, same matrix can be utilized. So what is happening here? Frame 1 with respect to frame 0, and frame 2 with respect to frame 1, and you can get the frame 2 position with respect to frame 0. कैसे निकल जाएगा? 0 के respect to 1 के देखिए 1 के, और ये you will get this position. How 2 is with respect to 1, and this is not simple translation. This is transformation matrix. Now this is not just translation. This is transformation matrix, which is including 4x4 matrix, which has rotation, displacement, and 0, 0, 0, 1. It has rotation 3x3, 0, 0, 0, and displacement and 1. Clear? Clear to everyone? So suppose they are describing what. Suppose one is rotating and translating relative to 0. What is the pose and orientation of one? That you can represent by these things. You can represent like displacement and rotation. Okay. We have like this displacement, rotation. ये आपको ऐसी matrix मिल जाएगी, transformation matrix. Okay, which is you can represent by 4x4 matrix. Every rigid body transformation can be represented as a rotation followed by the translation in the same frame. Okay. Then homogeneous representation ये है. The beauty of this transformation, again, this is inverse. If I can found, if I need to check the inverse, because what I'm looking, okay, this is frame 0, this is frame 1, this is frame 2. So frame 1 के respect में 0 की position में I can find easily frame 1 की इसके case में, frame 2 की with respect to 1 you can find 1 respect to 2. But if I need to go for reverse, I need to find the reverse, so I need to multiply the inverse of this one. Okay, so I need to calculate the inverse, and the beauty of this one is rotation matrix is what? Orthogonal matrix. So rotation matrix का inverse क्या होगा? Transpose जाएगा. Just row को column में बदल दीजिए 1 2 3 2 3 4. So transform क्या जाएगा? 1 2 3 2 3 4 हो जाएगा. तो ये काम हो जाएगा. 0 0 0 as it is रहेगा, 1 रहेगा. Only things we have to do, transform matrix multiply it. So inverse calculate करना भी आसान हो गया. ठीक है? So let us before concluding with my final remarks, I'm going to check that this is my transformation matrix. Okay, equation. So forward kinematics, we are moving like frame 1 position with respect to 0, frame 2 with respect to 1, and this way I'm going. Finally, this way I'm calculating forward times. Okay. So like this object, you have to pick. This is model frame 0 के respect में. तो आपको क्या position है frame 3 की with respect to 0. First we have to check the joint 1 position, joint 2 position, and effector hand कहाँ पे है, object कहाँ है, और position camera is required. This you can do link joint. This is forward kinematics. Okay. Forward kinematics. Already we have solved forward kinematics. Transformation you can easily do. Inverse kinematics, reverse you have to do. Okay. So inverse kinematics I have calculated θ1 and θ2. This PPT I will share with you. With this I will close my session here. Okay. So maybe bit before I'm finishing, because already I done. You can do some exercise also. Some assignment I will give you. In exam also I can ask. We have final day exam, so one question will come from this numericals, objective kind of questions. So okay, with this I will finish my talk here, and I will open for question answering. If any question, if you have, you can ask the question from me. This solution is clear to everyone. Let us explain this solution. Okay, the geometrical solution already is there. Trigonometry based solution also we can check, because I skipped these things. Trigonometry based solution I can explain to you within 5 minutes. I will try to finish this.
Any participants have any query?
So L1 cos θ1 plus L2 cos θ1 to y equal to L1 sin θ1 and L2 sin θ1. This is forward equation. If you take the equation 1, equation 2, दोनों का square लीजिए, 1 square plus 2 square, you can get here from 1 minute. Hello ji. Hello. Good morning. Hello. Because I have also not learned in the depth of this Euler utilities, but I know that this was utilizing for when drawn are moving. Okay, you can see that Euler angle, na? Euler angle, utility of Euler angle. In this is you can see that how Euler angle is happening. X, Y, Z, you are moving. Okay, maybe in your gear when car gear is shifting, that time also you can see that. The Euler angle are three angles introduced by the Leonard Euler to describe the orientation of rigid body with respect to fixed coordinate system. Utilities they have noted that can be also represent the orientation of mobile frame of physics in orientation to general three dimension. Chain rotation is happening. Popular Euler angle is ZX, Z, XY, Z, YZ, Z. So you can see that this is rotating like this, and you can see that the glimpse of this pendulum kind of things. Okay, so the different Euler, you are rotating around Z axis by certain degree, then X axis, then Y axis. Okay, utilities I will check. Application. I have also never checked this one. So I will not. CD-ROM, they are writing that searching capability of CD-ROM. Okay, CD-ROM report. More application of Euler rotation angle. This is rotation angle. Euler angle की क्या application हो सकती है? Maybe anyway, I will try to answer later on this question because I've also not exactly seen that I've heard it like this. Yeah. ठीक है, rotation. Application दे रहे हैं. Euler angle are used extensively in the classical mechanics of rigid body in the quantum mechanics of the angular momentum. Okay. This is concatenating rotation is the faster and more stable, extracting the angle of the axis. और भी utility होगी. Flight dynamics. Okay, that I was telling you, flight dynamics. You can see that flight is here, na? Roll, pitch, and yaw. So roll when you are just moving around your hand, x-axis. When you are moving, tilting around y, z axis. That. So an aircraft in the flight is free to rotate in 3 dimensions. Yaw, nose left, right, about the axis, pitch, and yaw. Okay, the axes are alternative design as vertical traverse and longitude representation. And these axes move within the vehicle, rotate around this one, and it is helping when you are landing. So it helps us to position when you are landing on that. Okay. This definition was analogously applied to spacecraft when the first manned space aircraft was in. Okay. These rotations are produced by the torque. Torque लगता है जब आता है हवा में turbulence आती है. That time also they used to balance the body, aeroplane की body. You can see that this explanation. Maybe next time I will come with this explanation. Okay. So for this time being, we'll stop here and we'll open for question answer. So Dharamveer sir,
Yes, sir. It was a very informative session on robotic kinematics,
okay.
and you have explained about different types of joint like prismatic and rotatory joints. So, because like how we can rotate with respect to axis. So that was rotatory joints and different types of rotation like 2D rotation, 3D rotation, homogeneous rotation, and actually you also explain about reverse kinematics, forward kinematics. So I think you have explained everything basic of robotic kinematics. So I request any participants have any question, we will unmute you. You can raise your hand.
I seen one question was there. How there? So you will get 3 rotation. Na? You get the Euler angle 1, Euler angle 2. What is happening? This question he has asked. The question is कि
कोई hand किया गया?
नहीं यहाँ पे लिखा है चैट बॉक्स में लिखा है इन्होंने लिखा सर will solving the problem of transformation and the matrix can we choose both your Eulers as well as roll pitch and yaw. So Euler is itself covering this. You see that what is happening Euler. I am not describe this Oriel orientation, but in Euler you can see that there is 3 different coordination of Euler is given. First, moving theta axis by z axis, then phi by theta, then theta around u axis, and psi around double axis. Similarly, Euler 2 coordination is there, roll pitch and yaw is there. So what is happening? You can combine matrix. You can do like this x y z. First में क्या कर रहे हैं? You are moving by the phi around the z axis. Then further you are moving around this u axis by the theta. So you can incorporate all 3 together. Now you are moving. So 3 angle rotation is there. This is one Euler configuration. So first you are moving around z axis by this one. Then you are moving around u dash axis by theta, which transform, and then you are double. You just multiply. You will get this matrix. Try matrix. So तीनों का results आ जाएगा Eulerian. Okay. This is for another coordinate system. So we will not go for this one. So this way you can apply. You will get combined matrix. Okay. I think no more question now here.
I think no any other participants asking question.
Okay, sir.
So we can conclude here, sir. So
Okay.
some participants are asking about PPT. So if you have any PPT,
PPT I will share, sir. PPT I will share to you, sir.
Okay, sir.
Because one or two questions will come from this
Okay, sir.
topic.
Okay.
So, okay, sir. Thank you, sir.
Thank you, sir. Yes, sir. Thank you, sir. Participants, we have another session on 12:10. So we have a break. So again, we will join at 12:10.